Good morning, friends. Today we will discuss about how to check whether a number is prime or not. So our objective is this: check whether a number is prime or not. Check whether a number is prime number or not. So before discussing this, we already discussed about how to check whether a number is even or odd. So first thing is I will go through that code first. Okay. So we have the number. First of all, we have to enter the number. Printf enter the number. I entered the number. Okay. So if I am using printf, I have to include the header file hash include stdio.h. So this header file I have to include. So I will comment this above line. Okay. So enter the number. Then I want to read the number. For that I have to create a number variable int n. Then I am going to use scanf %d and of n. So this will create the number. So I want to check whether the number is even or odd. For that what we do is we will use the if statement and we will try to perform mod 2. So what it do is that this mod function will give the reminder. Suppose we have a number 25, then 25 will be divided by 2 and we will get the remainder as 1. That means 25 is an odd number. And if it is an even number, suppose take the case of a 12, I am going to divide that number with 2. So the remainder I will get is 0. So what it means is that if the remainder is equal to 0, then I will say it's an even number. Okay, so I will say it's an even number. Printf, it's an even number. And else I will say it's an odd number. So this is a condition for checking whether a number is even number or odd number. Okay. The same concept I am going to use for implementing prime numbers. So what is a prime number? A prime number means a number which can be divisible by only one, either by 1 or that number. For example, 7. 7 is a prime number because 7 can be divided by 1 or by that number. Okay. Take another example, 16. 16 is not a prime number because we can divide that number with 2, so it's not a prime number. So what's the logic in finding whether a number is prime or not is that, so we have to check whether either it is divisible by, if suppose we will take the case of a number 7. So what we have to do is we want to check whether it is divisible by 2, whether it is divisible by 3, whether it is divisible by 4, whether it is divisible by 5, whether it is divisible by 6. So what is the thing is that if it is a prime number, what we are saying is that it can be divisible by 1 and that number. So what I am going to check is that if it is not divisible by the remaining elements. So we have the numbers in between 7, we have 1 to 6 numbers are there. So what we have said about prime number is that that number can be divisible by either 1 or by 7. So what's our logic is that we in between other numbers, and between other numbers means from 1 to 7 we have the remaining numbers are there 2 to 6. So we will try to divide that number with these numbers. So the same logic I am going to apply. Only difference is with even or odd I am only dividing with by 2 only. Now I want to check whether that number is divisible from 2 to 6. If it is not divisible from 2 to 6, then I can surely say that number is a prime number. So what I have to change is, I want to change this 2 to 2 should be changed and its value should be changed from 2 to 6. Suppose I am taking the case of 7. Okay, so what I am going to do is I am going to write a for loop for I equal to starting from 2, and it go up to that number. Okay, up to that number, that is up to suppose we are taking 7, then it range from 2 to 6. So I will increment that. So instead of 2, what I am going to do is that I will put I here. So what I done is that the same even or odd program is been modified, and now the logic is very clear. So what's the logic is that I am trying to divide that number with 2. Suppose we will take the case of 7 itself. 7 is divided by 2. It's not divisible by 2 because 7, when we are dividing with 7, we are not getting it as 0. If we are not getting it as 0, it means it's not divisible. So then what we have to do, we have to check for I equal to 3. Okay, so I have to check for 7 mod 3 equal to 0. So currently 7 is not divisible by 3, so we will not get the remainder. So remainder is not there, so it's 7 is divisible by 2, so we have the remainder. So we have the remainder, it's not equal to 0. Then we will go for 4. So I will take 4, 7 is divided by 4. Again we will not, this condition is not holding. I will go for 5, then 7 is divided by 5. So again equal to 0, but it's not equal to 0. So what it means is that it is not equal to 0. That means this 7 is a prime number. So we have to, if you want to check whether a number is prime or not, this condition should not hold for the number between 2 to 6. That's the logic. So now I am checking from I equal to 2 to 6, I am checking that. So suppose I am taking the number as 6. Okay, I will take the number as 6, or I will take the number as, okay, I will take the number as 6 itself. So so the range will be 2 to 5. Okay, so the range will be 2 to 5, 2, 3, 4, 5. So these I want to check from 2 to 5 whether the number is divisible. So initially 6 will be divided by 2, and we are hitting the value equal to 0. It's been hitted. If it is hitted, whether we have to check for 3 also, it's not needed, because already we know that 6 is not a prime, because 6 mod 2 equal to 0. So that means further checking of 3 is not required, because already we have understood that the number is not prime. Okay, so what we have to do is we have to stop the loop. So we have to stop the loop. So what we will do is that I will put a break. So break is a keyword used to break the loop. So break a loop is being breaked out. Okay. So else statement, this else statement is not needed here, because we just want to check whether the number is prime or not. So take the case of 6 now. So what happens is that if I am taking 6, I equal to 2, then 6 mod 2 equal to 0 is being hitted. It's true condition. So break will come and the statement will come out of this loop. So now we are in this point. But here we have a problem, because we don't know whether the loop is being breaked by using this break or by finishing the loop. So there are two possibilities are there for this loop to be breaked out. One possibility is that the for loop will be completely executed. Take the case of 7. If I am taking the case of 7, what we find is that it checked for 2, checked for 2, then 3, then 4, then 5, then 6, up to 6 it checked, and what we find is that the loop is been completely ended, and we come to this position. So now we are in a confusion because we have reached this position in two ways. One by completing the loop, and one by breaking the reaching the break statement. So we have to identify whether the loop is been completed or the loop is been breaked using this break statement. For that, I'm going to use a variable. I will put a flag value, just an indicator. Okay. If initially it will be set as 0. So if this condition is in hit edge, I will write flag equal to 0. So what's the difference of this code is that initially the flag value is 0 and we are in the loop. We are starting the loop. Okay, take the case of 7. Okay, so 7 mod 2 equal to 0 is not holding. So it will reach I equal to 3. 7 mod 3 equal to 0. It's not holding. Again it will reach this point. It becomes 4. 7 mod 4 equal to 0. It's not holding. Fifth value, if I become 5. 7 mod 5 equal to 0. It's also not holding. Again it will go to 6. 7 mod 6 equal to 0. It's also not holding. So the loop will terminate and we will reach this point. At this point, the flag value is only 1. So if the number is prime, the flag value will be 1. Okay. So take the case of 6. What happens is for 6 is that, so I have the number. Okay, so number is 6 is here. 6 mod 2 equal to 0. It's hit at, it's true condition. So we will come to flag. Flag will be set as 0 and the loop will be breaked using the keyword break, and we will reach this point. So at this point, what's the flag value? Flag value is 0, not flag value. So that means if the number is not prime, the flag value will be 0. So then now the code is very simple. I just want to write that the flag value is, if flag is true, it's 1, then I will say it's a prime number. Printf, it's a prime number. Else we will say it's not a prime number. Printf not prime number. Prime number. Okay, the line is being breaked out. Okay, so the simple code will check whether the number is prime or not. Okay, this program will just check whether it is working or not. We'll take the command prompt. have to declare the integer variable int. Enter the number 7. So we'll get return as prime. If it is 6, it's not prime. So the code is executed. So this is the code for prime number. So we will do one modification. Actually, here we are checking from 2 to n. But in real case, actually we don't want to check up to that value. Okay, we only want to check up to the square root of that value. So for that I will put that sqrt here, square root of n. So we don't want to check up to that n, we only want to check up to square root of n. Okay, so that I will include that header file #include math.h. Okay. 7 is here, prime, 6 is here, not prime. The same code is there. So only difference with this code and the previous code is that in the previous code we are checking up to that number or n minus 1. We are starting from 2 and we are just checking up to the n minus 1. But for this code, it is checking only up to the square root of n. So if the number hold the condition from 2 to the square root of n, we can surely say that that number is not a prime. So take the case of number 16 or take the case of 17. So the square root value is almost 4. So we will divide. First we will take the case of number 16. 16 is divisible by 2, so it's not a prime number. Take the case of 17. 17 is not divisible by 2, 17 is not divisible by 3, 17 is not divisible by 4. So it reaches square root of n. So up to, or we can say up to square root of n only we want to check. Okay, so it's holding the condition. Or we can put n equal to here also. So that is, it's checking up to the square root of n. That's enough. Actually, we don't want to check up to that number or up to n minus 1. So this is simple code for checking whether a number is prime or not. Hope you understand.